Okay, students, last time what I did was I finished set 4 on the first one. But today I want to do the b, that is integral square root x square minus a square. And we want to show why it is this form, and also you can write in the form of hyperbolic cosine inverse. So let me use integration by parts. The first thing I will do is integration by parts. You see this uv minus integral derivative of u and then v. So in this example, this is u and this is v, right? So this r will be equal square root of x squared minus a squared times v, which is x, minus integral of the derivative of the square root is 1 over 2 square root of x squared minus a squared, and then the derivative of the inside, which is 2x, because that will be 0, so this will be 2x here. You can clearly see 2 crosses out, this 2 will go away, and then I think I missed here again x is dx. Now this thing goes away, right? So this 2 is gone, cancels out. This x and this x will be multiplied to get x squared. And now in the radical, in the denominator, the radical is x squared minus a squared. So somehow I want to get this form on top. So I just push it to the left. So this will be x squared. And because there's a minus here, a squared, I'm going to write minus a squared and then plus a squared. And that first part we put in the parenthesis, which is exactly the same thing, right? And then we break this at this point, which is a plus b over c is a over c plus b over c. Use that and we can separate that. So I equals this x, well, let's rearrange this and write it in front of this radical sign minus. Now this distribute integral for the first part and then the second part, right? So the first part is integral of x squared minus a squared divided by square dx, and then this is minus into plus will be minus integral of, because that a squared is a constant, it will stay out, and this will be 1 over square root x squared minus a squared dx, correct? Then you can see, that the radical is the same thing. We can write this directly. Remember, the trick is a divided by square root of a is square root of a. So I'm going to write this directly. I will skip one step here and say, hey, just put a square on top and this is gone. So you get this form, right? And once you get this step, it's the same thing. When we call it as I. So I'm going to take it off and say, hey, that's I, right? Then add I both sides. So this goes away. And this will be 2i. So 2i equals x root of x squared minus a squared. And the integral of this we have seen from set 3 is ln of x plus root of x squared minus a squared plus c. Now, divide by 2. So this crosses out, and that's the main integral, which is square root of x squared minus a squared equals x by 2, and this is minus a squared by 2. And then you can see it's ln of x plus root of x squared minus a squared plus c. Now this plus c also can be written as, because this is times this part, can be written also as x by 2 square root of x squared minus square a squared. This will be cosine, so hyperbolic cosine inverse x divided by a. and then plus c, and you're done. That's all it is. So hope this helps. I think I missed here, this part I missed here, a squared divided by 2. Okay. By a squared divided by, there you go. That's all it is. I hope that helps, and it's always better to know how do you, question is why is this integral of x squared minus a squared dx is x by 2 square root of a squared minus, and so you have two forms, either you write ln of x plus this, or you can also write this one. And the right way is, remember, cosine, the hyperbolic cosine inverse x, this one, we want to write x by a, this is same as ln of x plus root of x squared minus ax, and then minus ln of a. So, hope that, because that's how the definition is. If I have an x by a, you have to subtract minus of ln a, and there you go, done. So next one we are going to do is another video. I show how to find integral of a squared plus x squared dx. That we'll see in the next video. Thanks for watching.